The idea of drilling a hole through the Earth's crust and reaching the other side has fascinated humankind since the dawn of civilization. What would we find on the other side of our planet? How would we get there? And could we survive the journey? These questions have been answered by the Kola Super Deep Borehole, the deepest hole ever dug by humans. Let's find out what secrets this hole revealed to the Soviets. In the 1970s, America and the Soviet Union were engaged in an intense space race where they competed to achieve milestones first and gain superiority over each other. But their competition also extended deep into the ground, with the US running Project Mohole and the Soviets launching the Kola Super Deep Borehole project. The aim was similar: to drill a hole deep into the Earth's crust to study rocks and geological structures. On July 24, 1970, the Soviets began drilling into the Earth with a team of geologists, geochemists, and physicists. Their first goal was to reach a depth of 3,500 meters. But as technology improved, the project kept expanding its goals. By 1989, they reached a depth of 12,262 meters, making it the deepest man-made point on Earth. For comparison, if Mount Everest was turned upside down and placed at the bottom of this hole, its peak would still be 3,592 meters from the bottom. The Kola Super Deep Borehole is located near the northwest coast of Russia in the Arctic Circle. The area was chosen for its relatively weak seismic activity and stable geology, which made it ideal for a deep drilling project. While drilling deeper into the Earth, the Soviets discovered some shocking facts about the inner layers of our planet. First, they found microscopic fossils of unicellular organisms 4 miles below the surface. This discovery challenged the understanding of how life could exist at such depth and raised questions about the origin and evolution of these creatures. Then they found traces of water where none should exist. The presence of water so deep underground challenged existing theories about the Earth's structure and raised questions about the origin and movement of this water. Finally, the temperature began to rise much faster than predicted. This suggested that the Earth's interior was hotter than previously thought, leading to speculation about the energy sources driving these high temperatures. At depths greater than 5 kilometers, the rocks experienced temperatures as high as 180 degrees Celsius, hot enough to melt most types of rock and equipment. In fact, some parts of the drilling equipment melted due to the intense heat. These findings indicated that the Earth's interior was more active and hotter than previously imagined. But these challenges only fueled the determination of the Soviet scientists. They continued to drill deeper and gather valuable data about the Earth's composition and structure. As they descended further into the bowels of the Earth, the Soviet scientists faced numerous technical challenges. The intense heat and pressure, combined with the need to extract long and narrow cores of rock, demanded innovative solutions. The team developed advanced drilling techniques and equipment to overcome these obstacles and retrieve samples from the Earth's crust. After several years of hard work and scientific exploration, the Soviet team achieved their goal of reaching a depth of 12 kilometers. At this point, the Kola Super Deep Borehole became the deepest artificial point on Earth, surpassing any previous human-made hole. This accomplishment was a testament to the hard work, determination, and technological advancements of the Soviet scientists and engineers. Reaching this milestone opened new possibilities for understanding the Earth's interior and expanded the boundaries of human exploration. However, during the drilling process, the Soviets encountered strange noises coming from the borehole. These sounds were described as groans, crackles, and moans, which were picked up by seismic sensors. Some reports even claimed that the team recorded screams and voices echoing from the borehole. The source of these sounds remained a mystery, leading to speculation and debate among scientists. Initially, geologists proposed that the sounds could be attributed to seismic activity, suggesting that the shifting and movement of rocks deep underground could create these unusual noises. However, others argued that the sounds were too consistent and regular to be solely due to natural seismic activity. They suggested that the noises might be caused by the release of gases or fluids trapped within the Earth's crust. This theory was supported by the discovery of gas hydrates in the region, which are formed by the freezing of water on gas molecules. As the drilling process progressed, it is possible that the disturbance caused by the drilling equipment could have triggered the release of these trapped gases, resulting in the production of sound waves that were picked up by the sensors. Despite the efforts to explain these sounds, some people believe that they held a more sinister significance. Some claimed that the sounds were evidence of a connection between the borehole and another dimension or a parallel universe. Proponents of this theory suggested that the drilling process could have created a portal or a breach between dimensions, allowing sounds from other realms to pass through. As the Soviets continued exploring the borehole, they hoped to unravel the mysteries surrounding these eerie sounds. By conducting further studies and analyzing the geological data, they aimed to shed light on the true nature of these auditory phenomena. Whether the sounds were explained by scientific principles or pointed to more paranormal occurrences, the Kola Super Deep Borehole continued to captivate the imagination and curiosity of scientists and the public alike. However, the incredible conditions at this depth made it impossible to continue the drilling process. By the early 1990s, several factors contributed to the end of the drilling operations at the Kola Super Deep Borehole. Firstly, the extreme temperatures and pressures at such great depths posed significant challenges for the drilling equipment and sensors. As the hole went deeper, the heat and pressure intensified, causing the materials used in the drilling process to degrade and fail. This made it increasingly difficult to maintain and operate the drilling equipment, eventually rendering it unable to continue. Additionally, funding constraints played a role in the termination of the project. Deep drilling projects are expensive and resource-intensive, and the Soviet Union faced economic challenges during the late 1980s and early 1990s that diverted funding away from such endeavors. The political changes and economic instability of the time also contributed to the end of the project. The collapse of the Soviet Union in 1991 led to a shift in priorities and resources, and the Kola Super Deep Borehole was no longer a national priority. Moreover, the scientific community began to focus on other areas of research, such as exploring the ocean depths and studying outer space. With the end of the Cold War and the expansion of scientific horizons, the urgency to drill deeper into the Earth's crust diminished. Before sealing the fate of the hole, the Soviets took steps to secure it. Once the decision was made to abandon the project, the open borehole was filled with cement and steel to prevent any potential hazards. This ensured that the hole would remain stable and prevent the collapse of the surrounding rock. Measures were taken to isolate the borehole from the surface environment, minimizing the risk of contamination or external influences. Today, the site of the former Kola Super Deep Borehole is marked by a simple structure resembling a well cap. It stands as a reminder of the remarkable feat of engineering and scientific exploration that took place there. The Kola Super Deep Borehole remains a topic of fascination and speculation. While the official scientific explanations offer insights into the natural phenomena occurring deep within the Earth's crust, some people continue to entertain more imaginative theories. The idea of a connection to other dimensions or parallel universes, though lacking concrete evidence, adds a layer of intrigue to the mystery. The sounds recorded at the bottom of the deepest hole on Earth continue to captivate the imagination. Whether viewed through the lens of science or paranormal belief, the Kola Super Deep Borehole serves as a reminder of the vast unknown that lies beneath our feet. Over the decades, the Kola Super Deep Borehole has been the subject of numerous scientific studies and analyses. Researchers have revisited the data and samples collected during the drilling project, applying modern technology and updated methodologies to gain new insights. Geologists and geochemists have re-examined the rock samples to better understand the Earth's composition and structure. They've used advanced techniques to analyze the minerals and isotopes present in the samples, providing a more detailed picture of the Earth's interior. These studies have helped refine our knowledge of the Earth's crust and mantle, shedding light on the processes that occur at great depths. Additionally, the original data collected during the drilling project has been re-evaluated using modern data processing and modeling techniques. This has allowed scientists to obtain a clearer understanding of the subsurface conditions, including temperature, pressure, and seismic activity. By reanalyzing the existing data, researchers have been able to fill some of the knowledge gaps and enhance our comprehension of the Earth's interior. These ongoing studies have the potential to unlock new discoveries and provide fresh perspectives on the findings from the Kola Super Deep Borehole. The re-examination of old data and samples in light of new scientific advancements has become an integral part of the scientific process. Scientists are continually refining their understanding of the world around us by revisiting and reinterpreting existing data. This approach has proven fruitful in various scientific disciplines, from astronomy to particle physics. By applying new models, technologies, and analytical techniques to previously collected data, scientists can gain fresh insights and challenge existing theories. Re-examining old data and samples allows researchers to benefit from the advancements in technology and the accumulation of knowledge over time. New instruments and equipment offer improved sensitivity, accuracy, and precision, enabling scientists to detect subtle patterns and variations that may have been overlooked previously. Moreover, the collective body of knowledge that has been established in a particular field over the years provides a valuable context for re-evaluating existing data. Scientists can draw upon a deeper understanding of the underlying principles, theories, and models to interpret data in a more comprehensive and accurate manner. The re-examination of old data and samples is also driven by the pursuit of deeper understanding and the desire to challenge existing paradigms. Scientists often revisit old data to test the robustness of their conclusions and to explore alternative interpretations. They may employ different statistical methods, modeling approaches, or theoretical frameworks to see if they can replicate previous findings or uncover new ones. So what do you think about the strange noises recorded at the bottom of the deepest hole on Earth? Do you think it's a proof that we shouldn't dig any deeper holes in the future? Or is it just a mere coincidence? Let us know your thoughts in the comments below. And don't forget to subscribe for more amazing videos.